Hey mathematicians! Today our lesson is 4 by 1 digit division using arrays, area models, and equations. Our TEK today is TEK 4.4e, represent the quotient of up to a 4-digit whole number divided by a 1-digit whole number using arrays, area models, or equations. Let's read our learning goal together. Today I am representing the quotient of a division problem using models so I can estimate and solve real-world problems. I'll know I have it when I can define a quotient, dividend, and divisor. I can explain the process of division, and I can represent the quotient of whole numbers using an array, area model, and equations. Let's take a look at our real-world connections. Arrays are useful in many real-life scenarios. They help us to quickly break up a total into equal groups so we don't have to stop and count. For example, egg cartons. If we know how to use an array, we can arrange the eggs in smaller equal groups using division. Models can help us understand and explore the meaning of math equations. They help us visualize what is happening in a word problem. For example, if we go apple picking, we can easily take our total and divide the apples equally among baskets to share with our friends. Let's go over our vocabulary for today's lesson. A dividend is the number that is being divided. So remember, dividend, divide in. Divisor is the number the dividend is being divided by. Quotient is the answer to a division problem, the size or number of each group. Remainder is the amount left over when a number cannot be divided equally. An expression is a mathematical phrase without an equal sign. Equation is a number sentence that shows two quantities are equal. So remember, equation has an equal sign. Equation equal. All right, let's go ahead and get started with our mini lesson. When dividing, you are taking a total and you're breaking it into smaller pieces. When you divide, you must put the same number in each group. When you know your total and number of groups, you can write an equation to help you solve. So your total divided by the number of groups equals the number per group. Let's look at a simple example. Hannah has 16 cookies and 4 plates. She puts the same number of cookies on each plate. We know there are 16 total cookies. The cookies are being put into 4 groups. So 16 cookies divided into 4 groups is going to equal n, or the number of cookies on each plate. We could also draw this using an array. We know we have a total of 16 cookies. We need to break them into 4 equal groups. Now that we've broken the cookies into 4 equal groups, we can complete our equation. So 16 cookies divided into 4 groups is going to equal 4 cookies per group. Let's look at another example. The Nacho Queso restaurant has 252 candies to be divided equally among 6 piñatas. Write an equation to represent the number of candies that will go into each piñata. We know that we have a total, 252 candies, that needs to be divided equally into 6 groups. So we can write our equation as follows using C for candies. 252 candies divided into 6 groups equals C, or candies per group. When writing an equation for an array, we must first count the number of items to find a total, then count the number of groups. So if I count these candies, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So I have a total of 35, and I have 1, 2, 3, 4, 5 groups. So we see that there are 35 total. We then can count the groups, which we counted 5. So our equation would read 35 candies divided into 5 groups is going to leave us with 7 candies per group. We also need to know how to interpret area model division. This model represents 1,456 divided by 7. We can use our knowledge of multiplication area models to break division models into groups of hundreds, tens, and ones. We can break 1,400 into 2 groups of 700. So I have 2 groups of 700 for a total of 1,400. and then break the remaining 56 into one group of 8. 56 divided by 7 is 8. If we total the partial quotients, we get a total quotient. So 100 plus 100 plus 8 equals 208. So 1,456 divided by 7 is going to equal 208. Let's look at our check for understanding. Write an equation for this array. Remember, we can use the equation total divided by groups equals the number per group. Go ahead and pause now if you need some time to formulate an answer. So our equation would read 42 candies divided by 6 groups is going to equal 7 candies per group. All right, let's do some guided practice. Lucy formed the following model of base 10 blocks to find her quotient of 256 divided by 2. Which is the correct quotient? So I'm dividing this total into 2 groups. So what I'm going to do is I'm going to take these base 10 blocks and I'm going to divide them into 2 groups. So here's one group. So I have 1, 2, 3, 4, 5. So I'm going to have to take 20 and then 1, 2, 3, 4, 5. So 20 and 5 for one group, and then 1, 2, 3, 4, 5, 6. Break that into 2 is going to give me 3. Let me use another color for our second group. So again, I have 100, 25, 26, 27, 28. So I have 100, 25, and 3. If I total those together, I'm going to get a total of 128. Garrett drew this model. Which problem is not represented by Garrett's model? So we are looking for a problem that does not fit with the picture that's being presented. So Garrett has 135 marbles. He divides them into jars by placing 15 marbles in each jar. How many jars does Garrett fill? So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 marbles in each jar, and he has 135 marbles. So I have 15, 15, 15, 15, 15, 15, and 15. So it looks like he's dividing them into 9 jars. So we would do 15 times 9, and we want to get a total of 135. So 9 times 5 is 45. 9 times 1 is 9, plus 4 is 135. So it looks like A may work, so we're going to eliminate that answer choice because we're looking for something that does not work. B, Garrett has 9 jars of marbles. Yes. Each jar contains 15 marbles. Yes. How many total marbles does Garrett have? Well, we just worked that, so that one is going to work, so we're going to eliminate it. Garrett has 135 marbles. Yes. He gives 9 friends a dozen marbles each. How many marbles does Garrett have now? Well, this I don't think, so a dozen is 12. So if he gives 9 friends, I have 9 jars, and then he gives each friend 12, but that's not what's being represented in this picture. It looks like there's 15. So maybe if it said if he gave his friends 15 marbles, so I'm going to mark that as a maybe because I'm not so sure that's going to work. Let's check letter D just to be sure. Garrett has 135 marbles. Yes. He divides them equally into 9 jars. Yes, he did that. How many marbles are in each jar? So we could also use that word problem for this picture. So I'm pretty confident now that answer choice C is our correct answer. All right. Miss Hunt purchased 5 computers for her classroom. The total cost of the computers was $2,550. Miss Hunt creates an area model to show the cost of each computer. What number should replace the question mark in Miss Hunt's model? So I think this 8 was supposed to be a question mark. So we'll go ahead and look at that. We're going to work it through just because. So if I know 5 times 5 is 2,500, I then have to ask myself 5 times what is going to give me 50. So I know it's not 8 because 8 times 5 is 40. So what times 5 would give me 50? The answer to that would be 10. So it looks like this question mark should represent 10. Good. Jeremy drew a picture of the eggs he and his family colored. Which problem cannot be represented by Jeremy's model? So I'm actually covering up part of this model. I'm going to move myself over here. So it looks like Jeremy has 12 eggs in each carton. So 12, 12, 12, 12, 12, 12. And then once we've labeled these, we'll count how many total we have in our groups, how many groups we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 groups of 12. So Jeremy helps prepare for an egg hunt. He has 144 eggs. He places 12 eggs at each hiding spot. How many hiding spots does Jeremy have? So we could probably figure that out using this equation. I know that 12 times 12 is 144. So if he is placing 12 of these eggs at 12 locations, I can just count the groups or the locations and I would get my answer. So that is going to work. So I'm going to go ahead and eliminate it. Answer choice B, Jeremy has 12 cartons. Yes, we counted them. He places 12 eggs in each carton. Yes, we counted that also. How many total eggs does Jeremy have? We just solved that, so this question would work, so I'm going to eliminate it. Jeremy has 10 dozen eggs. He places the eggs into cartons that each hold 12 eggs. How many cartons does Jeremy have? So Jeremy does not have 10 dozen. How many did we count? We counted 12. 12 dozen eggs we counted. So I'm going to mark that as a maybe because I don't think that's going to work, but I'm going to check letter D just to be sure. Letter D reads, Jeremy has 144 eggs. He places a dozen eggs into each carton. How many cartons does Jeremy use? So we know we have a total of 144. They are broken into groups of a dozen or 12. So that word problem would work. So it looks like answer choice C is actually the correct answer.